In question 2, the graph of y equals to f of x is transformed to the graph of y equals to f of 2x minus 3. We have to describe fully the two single transformations that have been combined to give the resulting transformation. Now, when we have a function f of x and when we write it as f of 2x, it means that there has been a stretch in the x direction, and the scale factor in this case, the scale factor will be 1 upon 2. And this minus 3 from the function, so if you have a function f of x and it becomes f of x plus minus a, it means there has been a translation, and the translation is in the y direction. So this will represent 0 and a. Now in this case, this is minus 3, so we'll write 0 and minus 3. So the two transformations, the first one is a stretch in the x direction, and the scale factor will be 1 upon 2. And the second transformation will be a translation with the translation vector 0 and minus 3, as there has been a movement of minus 3 units of the function in the y direction. In part B, the point P 5, 6 lies on the transformed curve f of 2x minus 3. We have to state the coordinates of the corresponding point on the original curve y equals to f of x. Now, we know that for f of x, there had been a stretch in the x direction, which had a scale factor of 1 upon 2. So we know that if there was a stretch in the x direction and the scale factor was 1 upon 2, it means that the x value was half. So it means that the original value of x would have been 10. And as the translation was 3 units negative in the y direction, it means that the original point had moved 3 units down. So as the point P is 6, it means that originally it was at 9. So the original coordinates were 10, 9 for f of x.